Hammer throw by Ibrahim and Osama. You might be asking, what is a hammer throw? A hammer throw is when a mass is attached to a cord that is spun around in a circle. It's an Olympic game. So as in these images here, you see the mass is being spun around a circle. As over here, the mass has just started to spin, and over here the mass is being spun, and right around here is when the mass let go. So the purpose of a hammer throw is to see to achieve the longest distance with the mass while spinning in a circle. So once you start spinning, you let go of the hammer, and you want the longest distance that is possible to achieve.
So what are the physics behind a hammer throw? Well, the two main topics behind a hammer throw is the dynamics part of it and the kinematics part of it. So first let's talk about this one, for example. So this guy's gonna put like a car over here on the track, and it's gonna go down the track and in a circle and then released. So when it's going down and goes in this circular path, that's the dynamics part of it, and then when it gets released, that's the kinematics part of it. So relating that to a hammer toss, you can say when the person is spinning in a circle trying to get as much speed as possible so that he can release it at a point where he can get the farthest and longest distance. So just to clear up things, dynamics part is a circular motion, the kinematics part is a projectile motion, and when it's released, there is also a dynamics part of it where the friction of air is acting opposite to it and gravity is pulling it down.
Circular motion. So let's focus on the circular motion of the hammer throw. Here's the FBD of the circular motion. As you can see, there's a radius, the force of tension, and the FC in the hammer throw. So let's focus more. So a hammer throw, there's a circular motion, and there's some stuff that you have to take in consideration, like the radius. So in the hammer throw, the radius plays a huge role in it, because the smaller the radius, the faster the hammer is thrown. So when you're doing a hammer throw, you don't want the radius being too big, because it'll be harder to gain speed and spin the hammer. Another thing that must be taken in consideration is the mass. Because in a hammer throw, if the mass is too big or too small, either the speed will be too fast or too slow, which gets me to my next point, which is the actual speed of the hammer throw. Because when you're doing a hammer throw, you spin with the hammer. As you can see, this guy over here, you can see him spinning with the hammer itself. So if you go too fast spinning with the hammer, you might just slip and fall down, which causes an accident right over here, as our friend right over here is falling down and the hammer hit him, which isn't good.
So now looking at the kinematics point of view of a hammer throw, this FPD can show us a lot of information, and one of the 5 acceleration key equations, this one. So we know that when the person is spinning in the beginning and then he lets go at a certain point, he needs to have a good initial velocity over here and an angle to get the maximum distance, and we can say that because of this equation, because of the initial velocity and the time it takes from the beginning to the end, and the longer the distance the longer it goes, the more time it takes. So the higher the number is, plus half times the acceleration due to gravity, which is always 9.81, and the time again, which can show us. And this is another point of view when a person is throwing it from the beginning to the end. So when we're talking about projectile motion, we also need to keep in mind when it's in the air about the dynamics part, because air is acting in the opposite direction, which can be also friction.
Hammer throw. Conclusion. In conclusion, we could see that hammer throw and physics relate really well. So athletes always have to take in consideration the physics and the science behind that sport. So in hammer throw, we realize that dynamics and circular motion kinematics and projectile motion had a huge impact in the actual throw. So in conclusion, we always have to take in consideration the physics, the science, and the actual sport. Hope you enjoy.